Now I need to configure. So we did the connection to vCenter. We specified that we want to do layer 3 connection across the management interface. That is that SVS domain connection. If I go to show run, that SVS domain here I specify what type of connection I have between my VSM and my VEM. So in this case it's L3 and not L2, and I'm using MGMT 0, or I could specify control 0 here. So I specified the connection, I'm using the default. I configured my uplink port profile, so now I'm configuring my layer 3 control profile. That layer 3 control profile, remember that VM kernel port is an SVI on my ESX server. So that is a virtual port, meaning I configure a virtual Ethernet port profile and not an Ethernet port profile. And I'm going to call this layer 3 control. This is not a trunk port. This is just an IP address that I want to place into a certain VLAN. So in my case, this is going to be switch port mode access. Switch port access VLAN 1. I'm going to place it in VLAN 1. And that's basically what I'm going to do. So I'm going to configure this as a VMware port group. No shut it. But before I do state enable, there is one additional command that I need to do on my layer 3 control port. And that command is called the capability command, and then I specify layer 3 control. When I enable this, it warns me about some things. It warns me that I need to configure a system VLAN, both in the uplink port profile and in my current port profile. So it means that I need to enable system VLAN in both the uplink and in this particular virtual Ethernet port profile. So what remains is state enabled and system VLAN 1. Now you see I have both an Ethernet port profile and I have a layer 3 control port profile. And that layer 3 control profile is just an access port on a switch that has the capability L3 control command on there, because that's a special port profile only used for layer 3 control traffic. And I configured system VLAN 1. Again, because I need this port profile to be up and running before I do the rest. Going back to my the list of things to do. Configured my layer 3 control port profile. Now what remains is that I need to give VMs, virtual machines, access to this Nexus 1000V. So I need to configure a port profile for my VMs. Let's check the box already, because I'm going to do that right now. I'm going to say port profile type virtual Ethernet my VMs. Just going to give that the name. This is also a switch port mode access port, accidentally in the same VLAN, could be in VLAN 10, could be in VLAN 20, any VLAN that I configure. This is also a VMware port group, it's no shut-it, state enabled. This is not a system VLAN port. This is just a normal port for hosting virtual machines. So it has nothing to do with bringing up the connection between the VSM and the VEM. That's when I need the system VLAN. It is just there to give VMs access to the network. So I do not need the system VLAN command here. So this can perfectly wait until the connection is established before it will allow traffic to go through. So I'm just leaving. I do not enable the system VLAN. So all traffic received in this port profile is being processed by the VEM and being processed by everything I can do with the Nexus 1000V. So those are my steps that I need to configure on the Nexus. What remains now is adding the ESX host into the distributed switch. So activating the VEM and placing the right links on the right groups. We configured these 3 groups now, so now we need to start allocating interfaces and ports in those port profiles. And that's something we do from vCenter. So again, nothing you need to worry about on the lab. These port profiles you do need to worry about. Know about that capability L3 control, because probably they have configured this correctly, but they forgot to enable the capability L3 control, or they forgot to enable the system VLAN command. All those things, those are things you need to think about for troubleshooting. So know exactly what you need to get this up and running. And again, you can run this in your own lab. You can download the Nexus 1000V and install it in your VMware server. So what remains is, I go to my networking configuration, my UCS class here. Look, I now have the layer 3 control, the uplinks and the VM's port group here. I'm going to go to my config section and we're going to say add host. In this add host wizard, I can now add hosts that I want to have in there. So I said I want to add server 3 and server 2. I have 2 physical network cards here. Those 2 network cards will be placed into the Nexus 1000V. I check the box and then I need to select which uplink port group are there in. So now you can see the order of operation. I first need to configure the profiles before I start adding hosts to my network, because I need all that information before I can add the host. Add them to the uplinks group. Done. Let's go next. Now it asks me, you have some VM kernel ports. Which ones do you want to migrate from your current vSwitch to the new distributed switch? In my case, VM kernel 1 is the one that I'm going to use because that has the IP address of 107 and 108 on the other. So I'm going to migrate them, or VMK1, to not to the VMs group. I'm going to map that to the L3 control group. Assign that here as well, layer 3 control for VMK1. Go next. Do I want to migrate virtual machines? I do. I have a Windows machine and I do want to migrate that to my new Nexus 1000. Because I'm in this server, there's now 1 VM running, and I want to migrate that to the VMs group. So this is just a client accessing the Nexus 1000V. Actually, let's just not do that right now. I will do this later and show you how it will be done. So to summarize, what do? I add some uplinks from 2 servers to the Nexus 1000V, and I add its VM kernel ports to the L3 control group. I finish that. And now in a couple seconds, I should get some messages that I detect servers in my Nexus 1000V. So it's going to do a lot of things. Hey, there we go. And there we go. If I do now a show module, it will show me exactly what I expect. So I see 1 virtual supervisor module and I see 2 virtual Ethernet modules. Don't look at the numbering because that's based on when they got online and what kind of UUID is assigned to them. And their names are Virtual ESX3 and Virtual ESX4, so that's all cool. They're running ESX 5.5, and I'm not running in an HA mode because I only see 1 supervisor. What happened to the ports? Show interface brief. Again, it's just NXOS. I see a management port. That's just the port that I have on my Nexus 1000V. Second, I see 4 physical Ethernet ports. My physical Ethernet ports are my uplink ports out of the server. So the server and its NICs, those are my physical ports. These ports are port channeled. Remember, we configured that port channel command. Here it says port channel 1, and module 6 is using port channel number 2. I see them here as well, port channel 1 and port channel 2. What do I see on port channel 1? It says inherit port profile uplinks. So use the settings from port profile uplinks. If I check interface /2, I also see inherit the port profile. And because it says channel group automatic, it will automatically add that to the port channel. Show port channel summary. It's not running LACP, it's running MAC pinning. So it's just running P and P mode, so both links are up and running. I have a graphical representation of this here in VMware itself. If I see the green socket, so the UTP connection here, it's a graphical interface of a UTP connection. If that shows up green, it means the port is up and running. Now it doesn't mean that this color is exactly mapping the actual interface state. It's not really working properly there. And of course, I have some CDP information, so I see that my neighbor is the UCS class switch, all working well. So my port channels are up and running through the configuration that I want to show interface trunk, just as I would expect on a Nexus switch. These VLANs are allowed, these VLANs are forwarding. VLAN 1 is forwarding. Why? I did not create VLAN 10 and 20 yet. Show interface brief again, I see 2 more ports. I first see the control port. Well, I'm not using that right now, so I can ignore that. I see 2 virtual Ethernet ports. Remember when we last saw the virtual Ethernet ports, we were talking about vNICs in the UCS. Right now we're talking about virtual Ethernet ports, and these ports connect to VMs. So show interface Ethernet 1, I have just show interface information as I would expect from any of my interfaces on the Nexus switch. By default, it will allocate a description of exactly what this port is. So I have 2 virtual ports right now, and they are my layer 3 control ports. So there are no VMs yet hosted in this Nexus 1000V. I see some packets already, quite some actually. So now to add a host, to add a VM to this Nexus, I go into my VMware client, I browse to the VM that I want to put into it. Here is my Windows VM that I want to put into it. It is running on server 4, remember that because you will see that later on. What I'm going to do is I'm just going to take its UTP cable and take it out of the VM network switch, and I'm going to insert it into the UCS class switch. Now as soon as I update this configuration, boom, I will see an extra virtual Ethernet interface. I now see 3 virtual Ethernet interfaces compared to 2. Show interface VETH3, and it shows me exactly that this is connected to the vWindows 1 VM on network adapter 1. And it's running on module 4. Who is module 4 again? Show module. Module 4, that's server 4. Just like as I would expect. Again, for the lab, expect to troubleshoot port profiles, expect to troubleshoot missing VLANs, expect to troubleshoot missing statements on the port profiles, like MAC pinning, like capability L3 control, like the system VLANs, know exactly what to expect on which port groups. And of course, this is a Nexus switch, so they technically can do any Nexus setting here, like private VLANs, like port security, like IGMP snooping, like IP-ARP inspection, all kinds of stuff. It's just a few points, of course, so they will not go as deep as on the as on the Nexus section in the lab, but they can go deep. But they will probably focus on the specifics of the Nexus, so that system VLAN stuff, maybe some allowed VLAN lists that you need to change, some native VLAN that you need to change, all kinds of things that you can think about for troubleshooting. I cover a little bit about QoS on the Nexus 1000V. Yes, I can. So the configuration is comparable to the Nexus 5K. So, or the Nexus 7K actually. There is no hardware queuing. So the network QoS type is not shown here. There are three types of QoS in the Nexus line. One of them is network QoS. That is really the hardware-based setting. But I can do queuing, so I can do bandwidth reservations, and I can do mapping, of course, marking of traffic. That's where this Nexus 1000V is made for. So currently nothing is configured. But where I would use QoS on the Nexus 1000V, it's not so much for queuing, I think. I would use it for marking traffic. So traffic coming in from a VM, specify the traffic and mark it with the right 802.1p bit or the COS bit. So let's do an example of that. So I just want all traffic from that Windows machine to get a specific COS value. So actually I want to specify what kind of traffic from that machine I want to run. So I'm going to configure an IP access list. Always need to. And it's going to call ICMP. I'm going to permit ICMP any because I want to match ping traffic. I want to prioritize ping traffic coming from my VM. So I do not specify any IP addressing because I know I'm going to apply this policy to the VM itself, to the interface of the VM. I'm going to say class map type QoS. It's called match ICMP, or let's say ICMP class map. I'm going to say match IP address, or match address. Match access group, name, ICMP. So match the access list that I just configured for ICMP. Next, I configure a policy map. So you know the basic concept of configuring QoS, right? We classify, we specify the policy, and we apply the policy. So we specify which traffic in a class map, and I configured an access list for that. And now I'm going to specify what am I going to do with that traffic. So ICMP. So this is the policy map for the Windows VM. In the class ICMP class map, I'm going to set some things. So I can set, for example, the COS bit to 3 or to 2. And I'm going to set the DSCP bits to class selector 2. So I can set a lot of values here, just mark the traffic with certain stuff. Now, that's the first thing that I'm going to do. So I'm going to mark the traffic. The second thing that I want to do is I want to prioritize traffic. So for the prioritizing, I'm going to need to use the QoS group command. What is the QoS group? I do not specify any IP addressing because I know I'm going to apply this policy to the VM itself, to the interface of the VM. I'm going to say class map type QoS. It's called match ICMP, or let's say ICMP class map. I'm going to say match IP address, or match address, match access group, name, ICMP. So match the access list that I just configured for ICMP. Next, I configure a policy map. So you know the basic concept of configuring QoS, right? We classify, we specify the policy, and we apply the policy. So we specify which traffic in a class map, and I configured an access list for that. And now I'm going to specify what am I going to do with that traffic. So ICMP. So this is the policy map for the Windows VM. In the class ICMP class map, I'm going to set some things. So I can set, for example, the CAS bit to 3 or to 2. And I'm going to set the DSCP bits to class selector 2. So I can set a lot of values here, just mark the traffic with certain stuff. Now, that's the first thing that I'm going to do. So I'm going to mark the traffic. The second thing that I want to do is I want to prioritize traffic. So for that prioritizing, I'm going to need to use the QoS group command. What is the QoS group? If I have a switch, in my case it's the Nexus 1000V, but I don't care what kind of switch. I have traffic coming in and I have traffic going out. I mark the traffic coming in, right? So this is my incoming traffic. Here's where I do my marking for QoS. Then I set the marking, so I recognize the traffic based on IP access lists, based on protocols, based on all kinds of things. I'm going to mark it with CAS bits, with DSCP bits. And because I want to have a bandwidth reservation for that traffic going out of the switch, so this is my outside traffic, I need to set an internal mapping on that packet. That internal mapping is called QoS group. I give it a number. I have 8 numbers for 8 queues that I can define. So what this prevents is that I need to do a double checking for the traffic. So if I want to mark on the in-band traffic, I would need to match on that marking again outside, going out of the switch. That would consume resources, because I need to check inside the header of the packet. So Cisco invented this internal value that I can add to a packet, and that doesn't consume resources, or a lot less resources. So I set a QoS group. Then on this side of the link, I can match on the QoS group. And because I can match on the QoS group, I can set, all right, hey, this is that ICMP traffic that we were talking about earlier, so now I can reserve some bandwidth for him. So set QoS group 2. Oh. So I can only do 2 things at the same time. So set the CAS bit and set the QoS group. And for all the other traffic, I have the class default. So I'm still in my same policy map. I'm going to set QoS group 0 and set the CAS to 0. So just to rewrite all the other traffic. So what did I configure? I configured an IP access list matching ICMP traffic. I said I classified that in a class map. And that class map, I applied that to a policy. And that policy says for ICMP traffic, set the CAS to 2 and the QoS group to 2. And for the rest of the traffic, set that to 0. Now, first I need to apply this to the interface. I can apply this policy on two places. I just said that I only want to allow the Windows VM to send that traffic. That would mean I place the policy on that virtual Ethernet interface. That virtual Ethernet interface will travel with that VM independent on which server the VM is hosted. It will have the VETH3 interface on all of my ESX servers. Or the other place I could set this policy is on the port profile. Then all the VMs connected to the profile will get this particular setting. In my case, I want to have that dedicated to the VM, so we're going to set it on virtual Ethernet interface 3. I'm going to say service policy type input. Oh, I don't care, type QoS input. And then I'm going to specify the policy map Windows VM. It's autocomplete. Sometimes NXOS autocomplete. And there we go. And now we can see that on virtual Ethernet 3, I applied the Windows VM QoS policy, and that QoS policy says this. So as soon as I'm starting to see packets matching, I will see them here. So let's match some packets. So I'm just going to open up the browser. I'm going to open up a ping to the internet. And now I see packets matching. So I see some other packets, that's just Windows stuff, probably some activation stuff. But now you can see I already matched a lot of packets to my ICMP policy. Now I still need to do the bandwidth reservation, remember? All I did now is classify the traffic. I did not specify bandwidth reservation. I need to do bandwidth reservations on the uplink. Bandwidth reservations are done in queuing policy maps. So again, what I'm going to specify is a class map not for ICMP traffic, but I'm going to match on QoS group 2. I'm going to say match QoS group. Oh, match cos, that's strange. That's strange. Usually in the Nexus, I match here on QoS group, but on the Nexus 1000V, it's different. I match on cos values, so that's good as well. And in this queuing, I can now reserve bandwidth for special protocols. There are some reserved protocols like the Nexus 1000V traffic or VMware traffic. Like, do I want to give NFS traffic some forwarding performance? Do I want to reserve some traffic for it? Do I want to reserve traffic for bandwidth for management traffic? All kinds of things, so I do not need to match the exact headers, the exact TCP headers. I can just use the match protocol statement here without performance impact. So these are very, very useful. And now I'm just interested in matching on cos2. I created a class map, so now I can start creating my policy map. Say this is my uplink output. I'm going to say for class QoS2, type queuing QoS2. I'm going to set, some bandwidth reservation for a percentage of the web value. So I'm going to reserve 10% of my bandwidth for ICMP traffic coming from the Windows host. There is no class default here. Because everything else that I do not allocate is advertised in, or is reserved for the class default. What did I configure? I configured a policy map type queuing where I match on cast2 and then I set a bandwidth reservation of 10%. So I'm going to apply this to all of the uplinks. So I'm going to apply this to the uplinks port profile. Service policy type queuing output uplink output. Now this change is now done. As you can see in VMware, oh, that's not a different task, so it's just the same. Going out of configuration, I say show policy map interface type queuing. And now I see that I've reserved some bandwidth for ICMP, and I also see that I already matched packets in this queue. I only see that on port channel 1. Port channel 2 does not match any traffic, so the VM is currently running here on port channel 1. So it's not a lot of traffic, of course. I can increase that maybe a bit. No, it's not very increasing a lot. Yeah. All right. So I'm not going to generate some more traffic actually. So that is a basic introduction to QoS on the Nexus 1000V. So just configuring class maps, policy maps as you're used to